Today we're going to talk about solving logarithmic equations, inequalities, as well as properties of logarithms. First topic, solving logarithmic equations and inequalities. Alright, so now we're going to solve this exponential equation, 2x equals 5. If you notice, both numbers don't have a common base, as well as it's pretty much impossible to find a number that has the same base. That would give us a 2 or a 5. So in those cases, we need logarithms. What I would do is use a logarithm with the same base for the left side, because that's where x is in this equation. So I would add a log base 2 on both sides. It doesn't matter what log you use as long as they have the same base. The reason I chose base 2 is so that the log base 2 and the base 2 for the exponent will cancel each other out, leaving only x on the left-hand side. But on the right-hand side, I now have log base 2 of 5. And I need to figure out what this is equivalent to. We're going to need a graphing calculator for that. So I believe you hit alpha window 5. Alright, and then for my base of my log, I'm going to put 2. And then in the parentheses, I'm going to put 5. So x is approximately 2.32. To solve for x in this case, both logs have the same base, which is awesome because it works just like exponential equations, where if they have the same base, this part cancels out, leaving me only with x squared minus 4 is equal to 3x. So it leaves you with what we call arguments. The parentheses are arguments. Since I have a squared term, that means it's quadratic, which means I need to move everything to one side. So I would move the 3x over by subtraction, and I would get x squared minus 3x minus 4 is equal to 0. You could then use the quadratic formula to solve, or factor if you remember how to factor. To use the quadratic formula, we need to identify our ABCs. A being 1, B being negative 3, and C being negative 4. So the quadratic formula is opposite B, so that means plus 3, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So that's 3 plus or minus the square root of, I'm going to do most of what I can without a calculator, so that's 9 plus 16 over 2. So that's 3 plus or minus the square root of 25 over 2. So that's 3 plus or minus 5 over 2, which means 3 plus 5 over 2, 3 minus 5 over 2. So our solutions are 8 over 2, 4, and negative 2 over 2, so negative 1. Now let's solve an inequality. Very similar way. I have log base 3 of x equals 4. I would first change this to exponential form. So again, this is the base, this is the power, and this is the exponent. This is the answer. So 3 to the power of 4 is greater than x. So 3 to the power of 4 is going to give me 81 is greater than x. Or you could say x is less than 81. I do apologize. This doesn't work quite like an equation, so I need to erase this, and I'm going to follow the format of what is above. According to what's above, we're going to put x, then greater than 3 to the 4th. So that means x is greater than 81. Again, I was using this format because it's a greater than symbol. So when it's a less than symbol, you still put x on the left-hand side of the symbol. So whatever the inequality is, put x or the argument, which is this, on the left. Keep it on the left. And it doesn't matter what the sign is. Just keep the argument on the left. So I'll help set this one up for you all. Oh, well, log same base, so the logs cancel out, leaving me with x plus 3 is greater than 2x plus 1. Finish it on your own. Now we're going to talk about 7.5, which is properties of logarithms. There are 3 properties that allow us to alter equations so we can work them out. You have to memorize them though. The first property says if you have a log and a base and your argument, in this case our argument is 6 to the 5th power, if your argument has a power, the power moves in front of your log. So in this problem down here, log base 2 of 10 to the 3rd power, this power moves in front of log, and it's the same thing as 3 times log base 2 of 10. If you have multiplication taking place inside your argument, so this is multiplication, then you can separate the two terms with an addition sign. So if I have log base 2 of 8 plus log base 2 of 10, it's the same thing as saying log base 2 of 8 times 10, which is then 80. So you can read it forwards or you can read it backwards and apply the property. Just make sure you use the correct signs. So multiplication becomes addition, and in reverse, addition becomes multiplication. And similar to the one we just talked about, if your arguments are dividing, then it becomes subtraction. And then if you have two logs subtracting with the same base, they have to have the same base, then you can put them back together as a division argument. So log base 2 of 30 minus log base 2 of 30. So the bases are the same. Therefore, you can combine these two to become 1 as log base 2 of 30 over 3, which 30 over 3 is same thing as 10. So let's practice. So log base 6 of x plus log base 6 of x minus 9. Since these bases are both 6's, I can take this plus and turn it and merge these two into 1. So that means it will become log base 6 of x times x minus 9 and is equal to 2. So this was property 2. I then want to write it in its equivalent form, so exponential form, to get rid of my logs. So that means 6 to the second power is equal to x times x minus 9. So this is in exponential form. Which means 6 squared is 36, and then x times x minus 9 is x squared minus 9x. So again, we have a quadratic situation. So we subtract 36 to give us 0 is equal to x squared minus 9x minus 36. You could factor or use the quadratic formula. A is equal to 1, B is negative 9, and C is negative 36. So x is equal to opposite of B, so positive 9, plus or minus the square root of negative 9 squared minus 4 times 1 times negative 36 all over 2 times 1. So that's 9 plus or minus the square root of 81 plus 36 times 4 over 2. So I need to know what 36 times 4 is. 144 plus 81, 225. Okay, so 144. So that's 9 plus or minus square root of 225 over 2, which is 9 plus or minus 15 over 2, which is 9 plus 15 over 2, and 9 minus 15 over 2. 9 plus 15 is 24 divided by 2 is 12. 9 minus 15 is negative 6 divided by 2 is negative 3. So all these logs have the same base, which is nice, but first I need to make the 2 on the left side become 1, and there's a subtraction sign in between, so that means my arguments have to divide. So that means log base 3 of 50, oh goodness gracious, of 56 over n is equal to log base 3 of 7. So this is property 3. Now that they have the same, now that it's down to 1 log on both sides with the same base, the logs will disappear, leaving me with 56 over n is equal to 7. And then I would multiply by n on both. Where is my mouse? I would put 7 over 1 and cross multiply. So I would get 7n is equal to 56. Then divide by 7, so n is equal to 8. My computer is not on my side right now. All right, I'm going to show you the first step, but then I want you to finish this one on your own. So this 2 in front of the log will go back up as a power. So that's log base 7 of x squared is equal to log base 7 of 27 plus log base 7 of 3. Now you finish solving that one on your own. And that concludes our